Let's take a look at one more example. On this one, in order to find the domain, we need to factor the denominator. So we're looking at t-chart factoring, what multiplies to a positive 12 and adds to a negative 8. Those values would be a negative 2 and a negative 6. Before you cancel, you need to give the domain restriction. So x minus 2 cannot equal 0, and x minus 6 cannot equal 0. So we get x cannot equal 2 or 6 when we add those values to both sides. Vertical asymptote would be x equals 6 because that x minus 2 factor cancels with the x minus 2 in the numerator, leaving us with a simplified version of our function of 1 over x minus 6. X equals 2 would be a whole, not an asymptote. Horizontal or slant asymptote, we can look at the simplified version of the function 1 over x minus 6, which reminds me of the parent function y equals 1 over x. Because the degree is larger in the denominator, the horizontal asymptote will be y equals 0. Just like for the parent function, the inverse and the inverse square have a horizontal asymptote at y equals 0. X-intercepts occur when the function is 0. Again, we can use that simplified version. Everything will be exactly the same for the simplified function as for the original function, except for that whole at x equals 2. Multiplying both sides by x minus 6, we get 0 equals 1, which is not true. This means we have no x-intercepts. Y-intercepts occur when we substitute 0 for x. This gives us a value of negative 1/6 for our y-intercept. Symmetry, we substitute negative x for x and see what happens. This will work in the simplified function as well. It will have the same symmetry as the original function. Now this looks like it might be an odd function because it's opposite in the denominator. However, we would have to factor that negative out, which would not give us the function we started with. That turns into a plus 6 instead of a minus 6, so there's no symmetry. Taking a look at the graph of this function, we had a vertical asymptote at x equals 6. We have a horizontal asymptote at y equals 0. And we had a y-intercept at 0, negative 1/6. We have no x-intercepts and no other information about this graph, so let's take a look at setting up a t-chart. We want to see what's going on around the vertical asymptote. I have to substitute 2 in because I know I'm going to have a hole in my function at x equals 2, and then I'll substitute in 4 and 5 to get kind of close to the asymptote and see what's happening. I can substitute this into the simplified version of the function to get what would be the y value if the x value was defined for 2. So we would have a y value of negative 1/4. Substituting 4 into the simplified function, we get 1 over negative 2, or negative 1/2. Substituting in 5, we get 1 over negative 1, or negative 1. Plotting those points, open circle at 2, negative 1/4. And then I can do a closed circle at 4, negative 1/2, and at 5, negative 1. So using the asymptotes, we can see that our graph is curving down and then approaching 0 off to the left. So to see what's happening off to the right, I'm going to substitute in 7 and 8 and see if that gives me enough information with my asymptotes. 1 over 7 minus 6 gives me 1 over 1. 1 over 8 minus 6 gives me 1 over 2. 7, 1, and 8 1/2. I can see it's going to curve between those asymptotes as well. There's no U-try on this one. These are quite complex and take quite a bit of time. So we can take a look at your assignment. What you need to do is look through the assignment tonight and choose one that you want to see as a class. If you don't have your answer right away, then your vote won't get counted.